Welcome to a discussion this afternoon of BECCS, which is Bioenergy Carbon Capture and Sequestration, and we'll be looking at the opportunities in air, water, and energy, specifically valves, pumps, scrubbers, IIoT, compressors, and filtration. And the McIlvaine Company is taking a somewhat different view, given our 40 years of experience in fossil fuels, and looking at the very good work that IEA and a lot of the institutions are doing. We have come to the conclusion that the potential is even bigger than most of the other researchers have determined, and we believe it's also proactive in that it can be bigger based on the input products and technology that the air, water, and energy suppliers can provide. In other words, there's a competition between various different technologies, and to the extent that BECCS can be made more competitive, it will be used to a greater degree. And in fact, what we believe here is that the actual parts per million of CO2, which have grown about 40 parts per million in the last 20 years, could actually be reduced down to where they were in the year 2000 if BECCS was instituted for all coal plants in the world. So you can see that there has been a substantial increase, and that the potential would be there for the reduction. So basically, the CO2 levels have gone to 400 parts per million, but at the same time, coal-fired capacity is not going down. It's at the very least going to be level through 2050, and is likely to rise slightly. So what's happened is that you've got China, India, Southeast Asia adding megawatts, whereas Europe and the United States are actually reducing megawatts, but the balance is a slight increase. If all the coal-fired plants were converted to bioenergy, the coal-fired power plant contribution would drop to zero. But if all these plants installed BECCS, the contribution would be a negative 7 billion tons. And this is a huge amount that would essentially offset other emissions, and we would be in a carbon negative situation. And this makes bioenergy stand out as unique, being the only really negative approach other than direct air contact. And direct air contact obviously would be a potential, but at this point in time, direct air contact looks to be in general more expensive. And when we talk about the bioenergy from coal-fired power plants, we're expanding our thinking there to look at a lot of other sources as well. We're focused in this particular presentation on the coal-fired plants, but the potential for sewage sludge, for waste to energy, and others is very attractive as well. And so each of these will have its place, but a lot of it can come from just replacing the fuel in all the coal-fired power plants. And this is something that Drax is moving forward on. They've converted a 4,000 megawatt coal-fired power plant to burn biomass, and this has been ongoing for a number of years. And they bought up reserves of forests and wood pelletizing operations in the United States. And so they have this huge enterprise to move these wood pellets to the UK and to burn them. But they're moving along with a lot of other technologies to not only burn the fuel, that gets you to carbon neutral, but then to sequester the CO2 in an estuary, as shown here, or along the way, the CO2 can be utilized in various different forms. And alternatively, hydrogen can also be produced from the biofuels, so that you have hydrogen and CO2 as two potential products. And Drax is moving ahead in a big way. And the approach is particularly attractive for Asian countries who are building coal-fired plants right now. So we're recommending to them that if they make their coal-fired power plants ready for biofuels, the cost of conversion at some point in time would be low. And it could be a two-step approach. You convert to the biofuels like Drax has done now, and then you put in the CO2 sequestration in the future, just as Drax has that underway as well. And when you start looking at the design of boilers, a fluid bed boiler can handle either the biomass or coal, whereas a pulverized coal-fired boiler is more limited in the fuel. So these are the kind of decisions that need to be made, but the potential is huge. So let's look at the bioenergy potential. Certainly a lot of the governments are behind the BECCS, and they're looking at net zero emissions, which says that there's many types of activities for which greenhouse gases are generated, regardless of the technologies that are available, and they have to be offset. So the direct air capture, or BECCS, is really the only way to have a carbon negative situation. And the transition to the low carbon economy requires what we see in green here, which is technologies such as BECCS, which provide a negative contribution. So you can, with the blue, you can see that solar and wind are bringing you down closer to the net zero, but you need the BECCS to go all the way. And our analysis shows that even compared to the solar and wind, BECCS is going to be playing a bigger role than IEA, for instance, believes it will. Well, we think that it's going to potentially play a bigger role, but it will be in part a proactive opportunity for the suppliers to make sure that they capture the carbon economically. There's all sorts of ways to do that, and that the combustion process is most efficient, and the bioenergy resources are low cost. And again, we've got coal. We've also got, we've got various forms of wood. We've got various agricultural products. And in fact, here's a list of some of them here, with forest residues and farm agriculture and organic waste. The waste to energy plants are a big potential. There are some waste energy operations that now gasify the waste, and this would be ideal for the bioenergy type approach. And when you compare the various different opportunities for reducing the greenhouse gases, the BECCS looks very attractive compared to alternatives. So we've done some analysis here of the amount of CO2 that is produced by coal-fired power plants, and here was what we came up with, which was a balance in the atmosphere that right now various different fossil fuels are emitting 14 billion tons of CO2 a year. So vegetable and land contribution is another 439 billion and tons of CO2. But it's also absorbing, with the growth of trees and so forth, it's also absorbing even more. So you've got a negative balance there. The oceans at this point in time have a negative balance as well, but that can go back and forth. But in total, you've got 12 billion tons of CO2 in excess that is going up into the atmosphere. In the future, new coal-fired plants are going to add some capacity. We've shown that from about 2 million megawatts, 2,000 gigawatts, it's going to go up to about 2.1 over the next 50 years. Another important aspect is the trillion trees, and we'll get into that in a moment. And the coal plant efficiency improvements are another way to get the equivalent of a couple billion tons of CO2 reduction. A biomass co-firing as opposed to total biomass firing is another option. But if you went to total biomass firing and sequestration, you're talking about reducing the emissions by 7 billion tons just with the bioenergy portion of it, as opposed to coal. But then if you sequester it, you've got another 7. So that gives you a 14 billion ton differential. And with these other net gains and losses from the land and oceans and so forth, you're in a situation where you are going to easily have a net negative CO2 contribution. And that means that you can take the 400 parts per million in the atmosphere now and work it back down so that there really isn't any tripping point. And we have a weekly alert that has this kind of information in it. Here's another company, this Future Metrics, that's come to pretty much the same conclusion that we have relative to the importance of BECCS and the using the coal-fired power plants. And it points out what I think is very important, which is a coal-fired power plant which can be converted to BECCS is much more economical rather than starting with a greenfield plant. You can use all the existing equipment essentially. If you've got a fluid bed boiler, you just switch fuels, and you've got scrubbers and particulate removal. You've got all the water treatment, you've got the boilers, you've got everything that you need there. So one, I think, important concept is coal-fired power plants actually are the most important resource for reducing greenhouse gases rather than being a liability if they were all converted to BECCS. So it completely changes everything on its head. Then we've got this trillion tree concept, and we used to have 6 trillion trees. Now we've got 3 trillion trees. But if we add 1 trillion trees back to the Earth, we act as a big carbon sink. And, unlike the BECCS, where you're using a managed forest and you never reach equilibrium, with 1 trillion trees, we would eventually reach equilibrium. You go from 3 million trees to from 3 trillion trees to 4 trillion trees. But at some point, those 4 trillion trees start to die off at the same rate you're adding new. So you eventually come to a balance, but there would be 50 or maybe even 100 years before that takes place. So the trillion tree aspect is one that is very important, and it has been backed by a number of organizations. Even the Trump administration was a supporter of that process. So there's lots of activity that we're getting into on a weekly basis here. Here's some examples. There's a lot going on at DRAC, so we're trying to keep up with that on a weekly basis. And on the UK itself, the UK is very bullish on BECCS. And so the DRAX is even doing things like working with a startup that would convert CO2 to fish food with hydrogen as the only other source. And another opportunity is to use biogas with gas turbines, and DRAX is working with Phoenix Biopower there. And this is a little bit more on that particular subject. Switchgrass could be a significant bioenergy resource. And Brazil is pursuing bioenergy in a lot of different ways, but the sugarcane bagasse is a huge opportunity, and it's already being utilized. So to create heat and power, and if you were to sequester that exhaust, then you would be achieving a lot as well. Kenya is considering water hyacinths, which is an interesting potential, and it's really something that needs to be eliminated there. And they're moving ahead in Brazil to the first negative biorefinery and with agricultural waste there. In Canada, you've got OPG, which is looking at being a negative carbon emitter. Sask Power in Western Canada is using coal, but is sequestering the CO2 there and has been a leader. And district heating plants is another very big opportunity, because you are able to utilize the heat as well as as generate electricity. And with a coal-fired power plant today, you see the big steam plume, but you're looking at a lot of inefficiency. So if you can also pick up the heat from the process at the same time, you've got even more economical operation. And so that's something that's going on in Europe with Acre Carbon and some other, and Microsoft and some others there. So that is there. And so UK is certainly a leader, and Schlumberger, Chevron, and so forth, and several other companies are moving ahead with the use of agricultural waste biomass, such as almond trees, to generate a bioenergy, and they're going to sequester that as well. And how this is going to impact the markets with fabric filters, you're going to need high efficiency fabric filters prior to the CO2 capture stage. By the time you get into the CO2 scrubber and the CO2 liquefied stream, you have to have very low particulate levels. So fabric filters, even for your initial particulate removal, make a lot of sense. Scrubbers, you've got more scrubbers than you would have with the conventional plant because you're not only removing the SO2 and acid gases, but you have to have a scrubber to remove the CO2 as well. And you have the normal catalyst for NOx control, but also for CO2 capture. You can have a solid adsorbent, and some of the companies that make catalysts for NOx are involved in some of these solid absorbents. And fan and compressors, you not only have the flue gas that you normally would have, but you've got the compressors to liquefy the CO2 and to transport it potentially long distances. Boiler feed pumps, you have all your normal boiler feed pumps, but also liquefied CO2. And in terms of valves, you've got thousands of valves needed for both severe and critical service. So the valve requirement goes up by about 2.5 times the coal plant and about by 5-fold over a gas turbine combined cycle plant. IIoT is also very prolific, and you need a lot of software, hardware, and measuring devices for that. We have coverage of all this on a weekly basis, along with all the plants in our utility tracking system and gas turbine and reciprocating supplier system. And we do customized, then we have all these reports on valves, scrubbers, and so forth, but we also do customized forecasts for any product. And you can see my email is Bob McElvain at rmcelvain@mcelvaincompany.com. And you can reach me by cell at 847-226-2391. I thank you for your attention today and look forward to talking to you. And I will sign off for now.